Hello and good afternoon, CSI258 Section 847 students for the second 8-week term Networking 4 course at Anne Arundel Community College. Today's PacketTracer tutorial is going to be on PacketTracer activity 1.4.1.2, which is the OSPF Skills Integration Challenge. And so this is the Partner Skills Integration Challenge to Skills Integration Challenge 1.4.1.3, which is where we were doing EIGRP. So let's go ahead and jump in. We've got our business has just expanded into a different town. We need to expand its presence across the internet, and we're tasked with completing the upgrades to the enterprise network, which includes dual-stacked IPv4 and IPv6 and a variety of addressing and routing technologies. So it says, although not required, adding additional labeling to the topology may help you as you proceed. So let's do our basic device configuration here. So it says configure the following on R1 and R4. So let's first do R1. So let's go ahead and click on that. And we're going to make this screen just a little bit larger here so that you can hopefully see it a little better. And we'll go ahead and jump into the CLI. And this is just a tad bit small here. Let me see real quickly on my preferences. I'd like to make that a little larger, so let's see here. And we want to do our fonts for the dialog workspace activity. I believe it's going to be here, so let's make it 14. Let's see if that, no, that's not what we wanted. I guess we'll do CLI. Let's check CLI, click apply, and now let's pull router 1 back up. There we go, much better. So we've got some more real estate here, and we've also got a larger font. All right, so it's asking us to set the device names to match the addressing table, and for us, we're going to go from user exec mode into privilege exec with the enable command, and then we're going to go into global config, where we're going to issue the hostname command, and that's how we set the hostname of the router, and it's just simply R1. And as we do these commands, if you look down here in the right-hand corner, you should see it's going to show you where you're at with your completion percentage. So we've got the host name correct. It says set Cisco as the encrypted privilege exec mode password. So we're going to say enable secret because that's a stronger password than a type 7 password. This is going to be an MD5 hash, and it is just Cisco. And let's see if they wanted an enable secret. They did. Okay, we're going to set the banner MOTD, which includes the word warn. So we would say banner MOTD, and now we're going to use a character that we're going to type in again once we're done with our message. So we would say here, warn, this is your official warning. And then when I'm done, I enter that character in that we entered in initially, which is that $sign. So now if I say, for the next command, set the IPv6 and IPv4 addresses according to the addressing table. And so let's come up here to router R1 and let's see. The first one we've got is interface gig 00. The first thing I'm going to do though, I'm going to say IPv6 unicast routing, because I'm pretty sure at some point we're probably going to need that. So let's then go ahead and go into interface gig 00. We'll say, excuse me, no shut. Set the IP address to 10.10.10.1. And the subnet mask is provided for us. It's 255.255.255.192. I'm also going to say IPv6 address, and it's 2001:DB8:A:10:1/64 and link local. There it is. So FE80 : oops, sorry about that. I'm going to have to put in my IPv6 address. FE80 : 1 link local. All right, that takes care of gig 00, and I think we did a no shut. Yeah, we did. Okay, let's make sure. All right, let's jump into the serial interfaces now. Serial 000, where I'm going to say no shut. Let's bring that interface up. We're going to say IP address is going to be 64.102.139.2, and they've provided a /24 for us. And now let's go ahead and do our IPv6, and let's get that link local out of the way. So we'll say FE80::1 link local, and then IPv6 address, our global unicast address 2001:DB8:A:64:2, and the prefix length is a /64. And that takes care of serial 000. Let's go ahead and go into interface serial 001, where we're going to go ahead and say no shut. And let's get that IP address on here right away. 10.10.1.1. And this is going to be a /30. And then IPv6 address FE80::1 link local. IPv6 address, where are we at there? 2001:DB8:B:1:1/64. And then finally, interface serial 010, we'll say no shut. IP address is going to be 10.10.1.5, and this is also a /30, so 252. And we're going to say IPv6 address, FE80::1, and we'll give it our link local. And then we'll say IPv6 address is going to be 2001:DB8:Baker:2::1/64. All right, so that takes care of router 1. Let's take a look here. What else do we need to do? And then assign the link local addresses. So the basic config for router 1 is done. Let's pull router 4 up, and let's go ahead and knock out the same tasks. And we should have a pretty decent sized font here. When we get to the CLI, we do. All right, so we're going to go from user exec into privilege exec, and then into global config mode. So let's get the host name done first. It's just R4. And now let's take care of the addressing on router 4. So let's go into interface gig, or actually, let me do the IPv6 unicast routing. I'm sure we're going to need that. So let's go into interface gigabit Ethernet 00, where we're going to say IP address 10.10.4.1. This is going to be a /24. And then we've got some IPv6 addressing, so we'll say IPv6 address, and this is going to be, let me make sure I got that first address right, 10.10.4.1, okay. All right, and then we'll get the link local address on here, FE80::4 link local, and then IPv6 address is going to be 2001:DB8:A:4:1/64. And did we say no shut? There we go. All right, then interface serial 001. Get that no shut in there right away. So we'll say IP address 64.103.17.2, and this is going to be a /30. And then we're going to say IPv6 address FE80::4 link local, and then IPv6 address 2001:DB8:alpha:103:2/64. All right, so that takes care of the addressing on router 4. What else did we not do here? Let's configure the enable password. So enable secret, and it's going to be Cisco. And the banner MOTD, so we're going to say banner MOTD with a $, and it's going to be warn, this is your warning. And then we end it with our $. All right, so that takes care of our basic configuration information. So configure SSH on R4. So remember, the first thing that we need to do, if we tried to generate the crypto key, if I said crypto key generate RSA, what's going to happen? It's going to actually give us an error message telling us we've got to do the domain name first. So let's get that done. And the domain name is simply going to be R4. So we're going to say IP domain name is simply R4. Now that we've set the domain name, I can generate my crypto keys. And it says that they're already there, but we're going to go ahead and replace them anyway. I'm going to say 2048. All right, so those keys have been created. And create a user of admin with an encrypted password of Cisco. So username admin, and we're going to go ahead and say secret. Let's see if they're looking for the secret here. Secret Cisco. So are they looking? And they are. We got the points right away for that. So they definitely wanted a MD5 hashed password, not a type 7. So configure all VTY lines to use SSH and a local login. So I'm going to say, whoops, line VTY 0 through 15. We're going to say transport input SSH, transport output SSH, and then login local. And that local just simply means refer to the local database in order to provide, or what's the word I'm looking for? In order to execute on the authentication of the user. All right, so that takes care of router 4. Now let's take a look. We've got some more work here on router 4. So it wants us to make router 4 a DHCP server. So we're going to go ahead and create a DHCP server. So I'm going to say DHCP pool. Oops, sorry, IP DHCP pool, DHCP pool. And the name of the pool is simply going to be R4. So now this is what it says here. It says assign the appropriate addressing information to the pool, including the 209.165.44.2 as the DNS server. So what are our options here? So we can do a DNS server. So I'll say 209.165.44.2. We're obviously going to be using a default router here as well. Prevent the address used by the router from being distributed to end devices. So that's going to be an exclude. But let's go ahead and get the network statement in here for the LAN on R4. So 10.10.40/24. So let's pull that up. So it's going to be 10.10.4.0. And then we're going to put our network mask in here. And that is a /24. Let me double check that. 10.10.4.0.255.255. And then we need to make sure we go back and catch that exclude. So let me make sure I get back and get the exclude in there. And then the default router, 10.10.4.1, which is the IP address of the, which interface is it there on R4? The gig 00 interface, which is our LAN interface here for PC5 and PC6. All right, so before I forget, let's make sure we get that IP DHCP excluded address in here. And the address we're going to exclude is the 10.10.4.1. And that's the address being used by the router. All right, so we've added the exclude in there. We've got our DHCP v4 done. Now let's go ahead, excuse me, and take a look at the NAT configuration. So we're going to be configuring NAT PAT on R4 so that all devices on the LAN use the IP address on the serial 001 interface to access the internet. We're going to use a single statement. There's also some PAT work that we're going to be doing, and then we've got some default routing here. So let's take a quick look here. I think I'm going to tackle the routing before we get into the NATing. All right, so let's go ahead. I'm going to jump down to the OSPF routing section, and we're going to knock that out right now. So configure OSPF v2 area 0 on R1. So we're going to step back over here to R1. I'm going to say exit. We're going to say this is OSPF v2, so router OSPF, and the process ID should be 1. All right, and what are we looking at here? So it says advertise directly connected networks do not include the link to the internet. And so that's going to be this link right here, which goes out to the 64.102 network. But the other connected networks are the gig 00 network and then these two serial interfaces here. So let's go up and take a look at the addressing table. It's going to give us an assist here. So the first thing I'm going to say, and did it ask to set the router ID? Yes. Okay, so we're going to set the router ID. Typically the first thing that I do is set the router ID, and I'm assuming no updates across LAN interfaces, so that's going to be passive interface gigabit 00. However, we're going to have some network statements, and that gig 00 network is going to be one of them, although it's simply just not going to send the OSPF hellos out on that LAN segment because there are no OSPF speakers there who can respond. So let's go ahead and get our first network statement in. So we're going to say network 10.10.10.0, and this is a 192, so it's going to be 255. Oops, sorry about that. We're going to going backwards. We need to have our wildcard mask. So 0.0.0 dot, and that 192, it's going to be a 63, right? Because again, remember, the wildcard mask is the inverse in 99.9% of the cases of the subnet mask. And so if I subtract 192 from 255, I get 63. And that is going to be in area 0. So now let's add in another network statement here. And this is going to cover the serial 001 interface. So this is 10.10.1.0. And this is a slash, I'm sorry, tied into the 10.10.1.0. And this is a slash 30. So it's 0.0.0.3, area 0. And then we're going to come right back with network 10.10.1. Now this could be a little tricky here because remember, it's not going to be 10.1 or 10.10.1.0 because these two address blocks that we're dealing with here let's make this a little smaller here. Drag it down. There we go. So the two address blocks we're dealing with, this one here and this one here, these are slash 30s. And so the first one, the network, is 10.10.1.0 because the first usable is 0. I'm sorry, the first usable is 1, right? .1 and then .2. These are our usables here. And then the net or the broadcast is going to be .3. So then the next network is going to be the 10.10.1.4. My usables will be 5 and 6 with the broadcast of 7. So for this guy right here, what we're going to do is, let me clear the screen here. We're going to say that the network is 10.10.1. Let me click in here. .4, and it's going to be 0.0.0.3, and then it's in area 0. And as you can see, our adjacencies came up. So now we've got our network statements in there. Let's see if there's any other OSPF information. So advertise directly connected networks. We did that. Do not include the link to the internet. We did not do that. So prevent routing updates from being sent across LAN interfaces. We did that. And then propagate the default route. So how do we do that? We simply say default information originate. So let's do a do show IP route and see what we're looking at here. Now, our gateway of last resort has not been set. However, we're propagating out the gateway of last resort to the rest of the OSPF environment. However, let's take a look and see what router 2 sees. All right, so we're going to go from user exec into privilege exec. Oops, and is it Cisco? It is. So show IP route. Let's see what we've got here. So take a look at that. The gateway of last resort is not set here. Even though we've got the default information originate, it's not being set. And why is that? I think further up, it may have asked us to create, and here we go, default routing. So we need to have, and this is what was missing, we need to make sure we have a default route, and it says use the next hop IP address. So let me come back over here to R1, and let's do that. Let's go ahead and set up a default route for 0.0.0.0, quad zeros again, and it says the next hop is going to be the IP, so 64.102.139.1. Now let me come back over here to R2. Let's rerun that command, show IP route, and there we go. So now we are picking up the gateway of last resort, and it's through router 1. And that's key to remember. You can also see that it's here where it's been picked up via OSPF. So we've got our default route. So on R1, configure an IPv6 default route using the exit interface. So I'm going to say IPv6 route :/0, and it wants the exit interface, which for the 64, let me go back up here for the internet, it is serial 000. All right, so we've got our two statements in there. It says on R4, configure an IPv4 and IPv6 default route using the exit interface. So let's go ahead and dump those routes in here real quick. So we're going to say IP route. It's going to be the quad zeros. And the exit interface is serial, let's confirm that on R4. Aha, it is serial 001. All right, and that's okay. And then we want an IPv6 route. So we're going to say : /0. Whoops, sorry about that. And I need the serial 001 interface in there. All right, and so we've added in the IPv6 default route. So that took care of the default routing. Let's step back down here to the OSPF. All right, so configure OSPF v3 area 0 on router 1. So let's go ahead and configure OSPF v3. So we're going to say IPv6 router. If I do a question mark, you can see there are our choices. So I would say OSPF, and then it's going to be followed by the process ID. Okay, so we want to get the router ID in here, which is going to be the quad 1s. And then it says prevent routing updates from being sent across LAN interfaces, so gig 00, just like we did with IPv4. And complete any required OSPF v3 or IPv6 routing configuration. So remember, with OSPF v3, there are no network statements, right? So if I do a question mark here, you can see we don't have any network statements. So the key to remember with OSPF v3 is that you simply enter the OSPF configuration underneath the interface on which you want that OSPF process to run. So let's go ahead and jump on to interface gig 00, where I'm going to say IPv6 OSPF area 0. Whoops. And I have that backwards. IPv6 OSPF 1 area 0. Overlook my process ID there. And now we're going to run the same command on the serial links. And in order to make sure I get the right serial links, let's take a look here. So we're going to do serial 001. So again, IPv6 OSPF 1 area 0. And then we're going to do the same thing under serial 010. So interface serial 010, IPv6 OSPF 1 area 0. All right, so we have an adjacency now, and there we go. So the other two adjacencies for IPv6 are up. So now this, we may have to come back, but it's interesting. It says complete any required. So as of right now, that's all I see that's required, although, let me check. Let's take a look real quick over on router 2. Let's close that down. And let's see, when we do a show IPv6 route, is it getting the default route? And it is via the directly connected serial, so it is picking that up. Okay, so we'll continue on here. All right, we've got our default routing, excuse me, which leads us to NAT. So let's take a look at the NATing that we're going to have to be doing here. And this is going to be the bulk of the configuration to get us through the rest of the exercise. So configure NAT PAT on R4 so that all devices on the LAN use the IP address on the serial 001 interface to access the internet. So use a single statement in access list 1 to define the addresses that will participate in NAT. Allow only the 10.10.40/24 address space. So let's go ahead and pull up router 4 here. Excuse me, I'm going to grab something to drink here. I'm going to take a quick pause. I'll be right back. All right, so let's go ahead and wrap up here with our NAT configuration. Excuse me. So we're going to configure NAT PAT on R4 so that all devices on the LAN, and let's take a look here over at R4, and you can see it's going to be PC5 and PC6. When they go out, we're going to go ahead and NAT those. However, we're going to use a single statement in access list 1 to define the addresses that are going to be allowed to participate. And that's actually pretty straightforward. So let's create our access list first. So we'll go from user exec into privilege exec, Cisco as our password, and then we'll go into global config, where I'm going to go ahead and say access list 1 permit. And what IP subnet range are we going to permit? It's going to be 10.10.4 because that is the subnet range on the R4 segment. So if I were to say do show access list, you can see we've got our statement there to permit the 10.10.4 subnet. So we want to enable NAT PAT using the access list. Excuse me. So what we're going to say now is IP NAT inside. If we do a question mark, you can see source. and then list, and then what access list are we going to use? It's going to be 1 on what interface? So we could use a pool, but we're just going to use that interface. And so our outbound interface there on R4 is the serial 001 interface. So we'll say interface serial 001, and we're going to go ahead and use the overload keyword. So I'll go ahead and hit enter, and that was correct. We actually got the points for that. And so now let's go ahead and wrap up. So we want to do interface gig 00, which is our LAN facing interface. We're going to say IP NAT, that's our inside interface. And then the interface where we're going outside is obviously going to be serial 0, and let me double check that. Is that 01001, where I would say IP NAT outside. And so that's going to take care of our NAT configuration. So that's our first NAT configuration here. Now we're going to configure PAT on router R1. So let's pull router R1 up, and PAT is a little more involved, and Cisco is our password. So let's go ahead, and I always like to do the access list first. So we're going to say access list 1 permit, and what subnet are we going to permit? It's going to be the 10.10.4.0, and let's double check that. Over here on router 1, the 10.10.4, maybe I was misreading that. So it's actually going to be 10.10.2 and 10.10.3 is what it looks like, and then 10.10.10. Let me double check, see what it's asking here. It says use a single, use a single statement. Oh, the /16. Okay, so we're going to just do a /16 and grab everything. .0, and then we're going to say 0.0.255.255. And so there's our single line access list. So now let's go ahead and create our NAT pool. So I'm going to say IP NAT pool, and the pool name is going to be R1. And it wants us to use all 4 of those addresses, 102.139.12. If I do the question mark, the ending address is going to be 64.102.139.4. And then the network mask is 255.255.252. Oh, I'm sorry, I'm going to put in the net mask 255.255.252, and then we're going to go ahead and hit enter. Start is on the same subnet mask, so it's asking for the 4 addresses. Let's see here. On different subnets. Whoops. Absolutely, they are on different subnets. I was off just a bit there. Pool R1. Oh, I made my change. So hold on one second here. So let's go to the end of the line. So we're going to say no IP NAT, and it's not found. So now let's pull back up the command that we want to use here. And let's go ahead and say IP NAT pool R1, and we start from 0, but I've got a feeling that it's actually looking for, and it states up there, so it says use a single statement, define a pool name R1, use all 4 addresses in the 64.102.139.4 address space. And I actually see the issue. I ran right by it. So 4 would be the network address, and I was thinking it was the network below. The first /30 was what I was thinking. It's actually going to be the second /30, so that's going to be .4 to .7, and that's going to be pool R1. So there we go. All right, so we've got that sorted. I apologize. I was looking at that address statement there completely wrong. Okay, so now we've created the pool. We've created the access list. Now let's tie that access list to the pool. So IPNAT inside source list 1 pool R1, and overload. All right. So we've got our overload statement in there. So now we're going to have to get on the interfaces. So R1's a little trickier because remember, we're actually allowing NAT. This is going to be our outside interface here because it's going to the internet, but we have 3 inside interfaces. So let's go ahead and jump in there. Start with gig 00, IP NAT inside, and then we're going to transition to int serial, and let's double check that on R1. Serial 001 IP NAT inside, and int serial 010 IP NAT inside, and then finally we're going to go to int serial 000 and say IP NAT, and this is our outside. So when the traffic is leaving out the outside interface, that is when we are going to NAT it. Okay. So the final thing we have, and these are actually static NATing is always very straightforward, and this is pretty straightforward. We're actually going to be doing some forwarding here. So, excuse me, let me exit out here, and we're going to go ahead and create R1. So use a static statement. So this is pretty straightforward. So we're just going to say IP NAT inside source static, because that's what we're creating. Now we're going to say TCP, so if I do a question mark here, we're going to do TCP because we're going to be doing the forwarding of the traffic, or redirection as they state it. So TCP, and then we always do the inside, so 10.10.10.10, and then what port? It's going to be 80, and then the outside address, or the way they refer to it is the question, the inside global. So I would say 64.102.139.2 to 80, and we'll hit enter. And then we've got another one where it's going to simply be very similar, but to 443. So 443, and then 443. And let me pause here just for 1 second. All right, so we left off. We're just going to go ahead and enter the 443 rule in, which is the additional NAT that we needed. All right, so we're at 92. So let's go ahead and let's check results here, and let's see. I think it may be something to do with the OSPF v3. And what do we got? Oh, I've got to configure the 2 PCs. And what is it looking for here? A default gateway on pool R4. All right, so it's all DHCP related. So, and I probably should have continued further here where it says configure PC 5 and 6. So let's come over to PC 5, and we'll go ahead and scoop up the points on this here. And so we're just going to come over and not config, but we want to do desktop. And we're going to say IP configuration, DHCP. And we should pull the requested information, and we even got our default gateway. So we look good there on 5. Let's pull up 6, and we'll go to desktop. We'll say configure DHCP, and we should immediately pull an address there. So everything looks great there. And so we're at 96, and we left off the default gateway. So let me double check. I want to make sure we get this right here. So it wants IPv6 auto config, but I'm looking for further down. Default gateway on pool R4 is incorrect. So let's take a look at the pool here on R4 real quick before we go back to the PCs. So we'll go to user exec, and I'm going to do a quick show run. And what do we have here? Aha, we do not have it here. So let's go into global config mode. IPDHCP pool R4, completely went right by that. And so you can see the options we have here. So we're looking, oh, actually we do have default router in there, but I put 10.10.14 instead of 10.10.4. So we're going to say no default router. So that is definitely wrong. 10.10.14.1, and we want default router 10.10.4.1, and that is correct, 10.10.4. So there we go. All right, So we've got that entered in, and now our final thing is going to be the auto config for IPv6. Pretty straightforward. So we say auto config there, and we say auto config here. And that should wrap us up at 100 out of 100. So there you go. There's our completion percentage. That's all the steps. We've got everything sorted out. You can verify web access. So let's give that a try. Well, I don't think we're going to do it from all 6 PCs. Let's just try from PC 4 here. Make sure that this works. So we'll pull our desktop up, and we'll go with the web browser, and we're going to type in to intranet or internet.pka. And let's see what happens here. Click go. All right, welcome to the internet server. So we've got access working fantastic. Pings are not forwarded from PC 5 and 6. Be sure to test both IPv4 and IPv6. Pings are not forwarded, so we're good. All right, well, that's going to wrap up PacketTracer Activity 1.4.1.2, which is the OSPF Skills Integration Challenge for Chapter 1 in the Connecting Networks course, which is the Networking 4 course at Anne Arundel Community College. I hope that this video has cleared up any confusion you might have had and clarified any steps that you were struggling with. And I appreciate you watching, and we'll see you on Saturday.